Don't hear any loopback.
Yeah, well. All right, I think we're live. I'm just going to go. Okie dokie, welcome everyone. My name's Peter Hansons, host of DataEng Meetup. We've been running this thing for about 5 years, and 2 years of which has been during COVID. So it's been a bit of an interesting ride doing live streams and stuff like that. Folks are slowly coming back into the office and figuring out sort of crowds and stuff like that. Great to see so many of you folks around for tonight. We've got two really good speakers. We've got Reva Kanduri. Is that decent enough pronunciation, hopefully?
Yes.
Solutions architect at Databricks. So she'll be taking us through one of their new features, Delta Live Tables for building declarative, scalable ETL data pipes. So that sounds pretty interesting, I'm sure. Wouldn't mind giving that one a spin myself. And then up next, directly after Reva, we've got Emil Pastor, Solutions Architect from Neo4j. He'll be taking us through reimagining recommendation engines using Neo4j Graph Data platform. So, graph databases are all the rage at the moment with data catalogs and stuff like that, but, been traditionally used for things like, recommendation engines and social networks and stuff like that. So really coming into vogue into data engineering. So both talks, I think, will be really awesome to hear. And just thanks so much to Databricks for hosting us. Just a few sort of housekeeping things. I think that the women's toilets are just there and the gents are a bit further down there. Pizza's coming directly after the talks. We'll have a bit of a chance to do some networking, things like that. I forgot to mention we've got DataEng Hack happening on the 28th of April. Massive shout out to all of our sponsors, Neo4j, Snowflake, Fivetran, of which I've got a couple of representatives here, Microsoft Azure, DBT Labs, Databricks, DataStax, ThoughtWorks, AWS, Imply Reactor, Cloud Shuttle, and CloudSeeder. So thanks so much for all of our sponsors. Tickets are only $49. I know a lot of us, our wardrobes are getting pretty thin on the ground with, really good quality swag, and it's coming into winter, so we need to restock, am I right? So there's some really good socks up the back and caps as well, but I think you're going to get a really good opportunity to restock at this event. So definitely encourage you to get a ticket. It's going to be a really fun day. I'm sure you're going to learn a lot, so it's going to be fun, but you're not here to listen to me gas bag all night. We're here for Reva and Emil to hear some really great talks. So without further ado, take it away, Reva.
Thank you. Thanks, Peter. Thanks everyone for actually taking our time and coming to our office. This is actually our new WeWork office, we started in Jan, actually. So it's nice that we're actually building up. We were in a much smaller one, and now we are like 80 capacity, and hopefully we'll become much bigger, right? So I think, Peter, did you mention this? There's drinks in the cooler. Please free to take it whenever you want. So today we're going to talk about Delta Live Tables. It's a feature that was recently GA'd a week back, basically. The reason, it's always starting with the reason, right? The reason why we focused on Delta Live Tables is, data engineering, Databricks definitely is a more data engineering oriented persona when we started with, right? Which was all with Spark and Delta and creating all those tables and how you get all your good data into your data lake. I'm sorry, the visibility is a little poor. It's the best that we could do at this moment. Maybe for the next one. Now it's censored and controlled. So if you see that when you're trying to build your data pipelines, there is actually one more table link that you see. And what you're trying to do is your actual code that your ETL engineers are trying to do is just that red part there. But around it, the periphery of it is where you're doing your dependency management, your Git versioning, your infrastructure, your governance. So there's so many aspects that you have to think around before you can actually do that one piece that what your data engineers want to do, right? And also, SQL is another favorite language for a lot of ETL engineers, right? And it's not easy to productionalize your SQL pipelines. So thinking these in mind, That's where Databricks came up with a modern software engineering for ETL processing, so that you can do all of these things, but in a managed style. So think of it like you as an engineer are only focusing on doing what is really required, that is taking the data, transforming it, applying the right logic, whatever you need. But the infrastructure, the management, the version control, and some of those complex scalability point of view is managed by Databricks. So it makes your life much more easy, right? So that's where Delta Live Tables came into picture. Obviously, it's Delta Live Tables, so it works with Delta Tables at the back end. So it's a declarative style of ETL pipeline framework. So the idea is you can focus on accelerating your ETL development, and some of the challenges like automating your infrastructure or scalability point of view, or having the reliable data quality and all, leave it to us. We'll take care of ensuring that you do a good job there. It supports both streaming and batch ingestion. That's also because under the hood, Delta itself supports it. So that's why Delta Live Tables can easily take that capability and work with that. Don't worry about the code that you see. I have another slide with a little more enlarged view of it. But idea is basically, instead of saying, what is it that instead of focusing on, okay, I write this logic and how should I productionalize it, you focus on what. So you can use, so it's very similar to your SQL constructs, like saying, create this or create that, and having those SQL constructs behind, similar idea, but it supports SQL and Python language behind it. The example here is just showing you SQL, basically, right? And what it does under the hood is, based on the way you define your constructs, it creates a lineage table for you. So it makes you easily you view it from a UI, how your tables are dependent on other tables, and it gives you that visual approach of understanding how your pipelines are going to run and how it changes the effects of one on the other, right? This is the code which was there basically here, and I'm trying to show in an enlarged way. So when you say incremental, when you say create table, instead of saying create table, you say as create incremental live view. And what it does is it's creating a Delta Live table there, and you can do and what you're doing is like as an incremental stream kind of job. So even if it is like a batch data for you, because you're saying as a create incremental live view, you can make it like a streaming way and make it small incremental kind of pipeline building. It's it can be a little bit new way of looking if you're always done only batch kind of jobs, right? And like within like 7 or 8 lines of code there, what I'm basically doing is I'm creating a table, ingesting all my raw data files into it. I'm creating my bronze or the raw table out of that. And I'm curating, and I can create some logic in my silver table there and say that, okay, from this table, using my previous, the previous tables that I've created, which is what the lineage is detected there. And you're saying like, okay, this is how I want to create this table. And nowhere you're focusing here on what side of cluster I want to create, what kind of version I want to use. And all those things are at the back end taken care by Databricks. So that's the declarative style of it. And if you look at some of more interesting or differentiating features, is, as I said, you can do a continuous or a scheduled data ingestion. So autoloader is one of the interesting feature which we released a while back, right? And what autoloader does is, if you have, say, for instance, like an IoT kind of data where you have a lot of files coming into your storage account, autoloader can easily manage in ingesting from your cloud into your Delta Lake. So the first step of getting into your Delta Lake is what autoloader can easily streamline it for you or automate it for you, basically. So when you combine autoloader with DLT, what you get is a powerful way of doing your ETL pipelines, right? Because you're incrementally processing as and when the data comes, or you can even schedule it, right, if you want to. And at the same time, autoloader has its own infer schema method. So let's say you have a file coming in, you want to know what is the data types, what are the columns, but you don't want to actually emphasize it, it can still detect that. And it can also evolve the schema. Like we all know, your business changes, right? Your applications changes, the kind of data getting collected, that changes. But because with autoloader, you have schema evolution method, it can easily detect it and ensure that the actual data in your tables is not getting somehow corrupted with wrong columns or wrong values, right? So yeah, that's quite powerful for especially like streaming use cases, right? Change data capture, again, an interesting scenario, or maybe a day-to-day scenario for most of the engineers, right? You are trying to get only the changed values or updated values from your source systems for your applications or whatever other source systems that you're ingesting. And you just want to get that data into your data lake, right? Again, within Delta, we have change data feed capturing, so you can capture all of that data that you want. But how do you think of when you're thinking of enterprise level, several tables and several source systems where you have to incremental? You don't get hundreds of changes all the time, but sometimes you can get very little, sometimes you can get a lot, right? But you want, the trick is having the simpler architecture, but somehow able to control when you want to do what, but do it easily, right? And that's where this change data capture, it can capture all the row-level changes for you, streamline it, stream it as a streaming ingestion, and then you can capture it together into your silver table from all your different sources. Again, it can do schema evolution because under the hood, Delta can manage that. This, again, I think this is the example that I've enlarged it here. So what you're doing here, sorry, this is a different one. As I said, the main thing when you think of ETL pipelines, it's not enough just to say, oh, I did my job, it's working, I tested it, it's fine, right? As and when you keep going, you'll have some issues coming up, some wrong data coming up. And I say wrong in the sense like your business process changes their rules, which means you might have done the change, but maybe the data source side it's not completely adopted. Or maybe the data source side it has changed, but the business process is not adopted. Now think of it when you're doing it for a high enterprise level, like petabytes of data. You can't just go back and try to change that value. It's just a nightmare for you, right? I mean, imagine if you are, for example, a certain ID has to be certain values or certain type, and you just didn't consider that in your ETL pipelines, then you're basically trying to, do a lot of midnight oil burn to just reverse back to original state. But with Delta Live Tables, what you can do is you can set some sort of constraints or with what we call as expectations. These are basically some sort of data quality checks that you can write, again, in a declarative SQL kind of fashion, where you can tell what is the kind of data that I expect for certain columns. And when that expectation is not met, what kind of operations do I want to perform? So in that way, you as an engineer are very much in control of what kind of data you want to actually ingest into your pipeline. But how do you know that, right? How do you know that it's working? So that's where we also have a GUI that can show you, when you run the pipeline, it can show you which are, like, as you run, let's say you are doing testing, as you run it, you can easily see how many of the data entries have actually failed that expectation. So you have a very easy way to know, okay, whether it's working and how well it's working. And on your real life pipeline also, you can easily see the kind of issues that your data is producing when you're running it. So then you have two options, right? You can either go back to the source, try to figure that out, or at least raise a request to the business process so that you have the right people looking at it. And it's all about having control on your Delta and having a control on your data quality. That's the main point behind it. Yeah, exactly what I've said here. And one thing I wanted to mention is when you're doing this, you have some logs and metrics generated at the backend. So effectively, within your data engineering teams, you can also have some sort of a quality dashboard or KPIs that can actually show how well your team is performing or what your challenges you're having or how's your data coming in, all sorts of metrics to just show where are the issues or how you can rectify them, right? And this slide, what I'm showing here is a very nice transition to what I mentioned right now about observability point of view. You're not just building for one time, you're building for a very long time to sustain your pipelines, which means you really need to have a good observability, where you can easily identify the challenge and easily also identify when something breaks, right? So what you see at the top, again, it's a very, sorry for the light, and you can see like this green box lights, which are basically like boxes, right? Each of those boxes represent the tables or tasks that we have mentioned earlier. And what it Delta Live, the DLT UI feature itself, it can create that lineage diagram for you. So when you're writing the code and you're about to run the pipeline, it creates that lineage DAG for you. You're not doing it with hand or anything. So it's trying to show you, based on the code that you've written, this is how your table dependencies are looking like. And you get an easy view of how my whole pipeline is interlinked. So even if you have to change certain tables, you can know easily how the change looks for or propagates to the other tables. If anyone have worked with DBT, this is a very similar experience that you'll have there, right? But in addition, as I mentioned, because you're always monitoring and there's a lot of granular logging that you are doing for your operational governance and quality, you can also have all that created as sort of a data quality metrics that you're seeing here. You can continuously monitor your pipeline, and you can see easily from your dashboard itself, like how your overall pipeline's health is. But you can also see how your overall data health is, right? Now you can see if there are some columns that are getting dropped. So for example, what you see here, I'm setting, these are my different expectations, like my constraints. I'm telling, and I can define whether to drop or expect them or totally cancel the pipeline. And you can easily see them with your dashboard or UI, basically. And you can also email this dashboard. We can build it off of Databricks SQL, which is, again, one of our other feature offering as part of a unified data analytics platform where BI analysts can work on Databricks. So using that same feature of DB SQL, you can build a dashboard there in that, and which uses the same delta tables which your engineers have created. So the whole idea of here is Databricks is focusing on just having a unified platform, but at the same time focusing on making it simple for users to easily access it and more focus on the job that they are meant to do rather than the job they have to do to manage it. That's the difference that we are aiming towards. Right, so once you build the pipeline, so as you see here, each of those features is catered for as you go through your lifeline of your pipes, how you want to handle them, right? So once you build a pipe, the next thing is you want to productionalize it, right? Which is where we bring all your software development ideas of CI/CD, right? You want to develop in a safe place, you want to have the ability to test it, and then you want to deploy it. Now, traditionally, SQL was not something that was really suited to do it. All the Python coding or whatever other coding languages you have, they are pretty good. But SQL, building a SQL pipeline and productionalizing it is quite a hard challenge. But now with DLT, what you can do is you can sort of parameterize your pipelines. You can change what are the data sources that it should land into, what is the tables that it has to land into, what are the different, you can have set different parameters for your dev, prod, and test environments. And that way you can easily do your development without affecting your production environments, but also have a simpler way of managing the deployment between these two different environments if you want to. Right, so I guess this pretty much covers most of the typical tasks that you want to do with your data engineering pipelines, right? You want to do CI/CDs, you want to do version. Of course, when you're thinking of CI/CD, if there's a version control at the back end, all your DLT pipelines that you build, you can have it as notebooks, which you can version into your repos, and then basically have a version control behind it, have more governance around it on who can change them accordingly. But there are some interesting features more coming up. Now, DLT, as I mentioned earlier, we're creating it as an incremental live view, which means we are telling it as, even though it's a batch kind of data transformation, you can do it as a streaming. The reason we are also looking towards is we do see that over the long line, there would be more streaming use cases coming up. Even if it's a batch job, you have more tendency to probably go towards streaming, making into streaming sort of use cases. because streaming is more incremental. You need smaller computes. You can do it faster that way, right? It's all about speed and agility at that point. So from that point of view, there's a new, this is an in preview feature on DLT. So the idea here is, again, if you have an incoming streaming source of data, you basically have, there's a smart logic, let's say smart logic for the sake of simplifying it, right? There's a smart logic at the back end which will actually monitor your backlog information and also understand your utilization, how you're doing it, and then somehow scale your compute systems such that you can do accordingly that level of adjustment in your scalability of your pipelines. So what it means is tomorrow when you are actually having to run more jobs, you don't have to worry about whether my pipeline will handle, whether it will break, or whether I have to test and trial and error just to see what would be the right cluster types. This will take care of it internally for you. So these are some of the upcoming features we do have, like partial updates and Unity Catalog integration. So Unity Catalog is a new feature that Databricks is releasing, which focuses on how you should think of governance when you're talking from a data lake or an enterprise data lake point of view. It's still yet to be coming into private preview and GAs and all that stages. But the idea is you can publish your Delta Live tables into Unity Catalog, and you can manage it from there for all of your different teams on how to access it and perform with it. There's other interesting features like custom libraries that you can add on it. So with Python, it can already support it, but more specifically to data engineering point of view, how would you like to have more customized libraries or your own imported or specialized created libraries for your own team, how you can use that. There's all other features like that that are being released with Delta Live tables. I do wanted to show a demo, but because of the lack of quality with our video right now and the presentation, I'm short of doing that. Do you have any questions? Yeah.
Yeah, relatively minor question. For exception handling, there was the options of alert and quarantine. Does it have syntax to say do both alert and quarantine?
Sorry?
Well, when you so basically blah blah blah, except violation.
Yeah.
I think there are options to send an alert.
Next slide.
Send an option of quarantine. Is there an option for alert and quarantine to do both at the same time?
Yeah, you can set that effectively. It's just up to it's a user specific way. It's a user defining, okay, set me an alert, right? It's not by default doing it. You can set an alert, and of course it will quarantine the code for you, the rows for you. It won't so in this case it's actually not quarantining, it's just dropping those.
Yeah. So you can do two things at the same time.
Yeah.
Okay, cool. That's good.
Any other questions?
Actually, I have a market question. You were talking about streaming and the use cases increasing. Just what's your overall take on the market? We are also seeing more requests for streaming, but when we click into it, they're not always a hard requirement. It's like, well, of course, why wouldn't you want streaming instead of batch? It sounds better.
So when I say streaming here, I'm not saying as such like the data itself coming as streaming. So what I'm saying is you can have like, nightly job which extracts the whole of the data, right? But say if you want to process the whole of it, you have an option to do it in a streaming fashion where you're you're doing in a small chunks. That's also a streaming that we are talking here. We are not talking only like IoT sensor data or only those particular use cases. Do you understand?
I do. I'm still wondering what is driving the demand for that, for your use case that you just described. Internally, you have the choice between batch Delta loads and actually streaming internally.
Yeah.
What users are saying we really need that to stream instead of to be in an incremental batch of 5 minutes, an hour, overnight.
So, Joe, you want to answer that? What are you thinking? Like, I'm not sure. What is the market update so far? So,
with streaming, you've kind of got this. I forget how that triangle goes. It's about how real time it is, how much you want to spend, and how complete should that processing be, or whatever. And so you've got these three things pulling against one another, and you kind of need to make a decision about which are the important ones to you, and the more robust and real time you want that to be, the more expensive it actually kind of gets. I think one of the really cool things we've done with Delta-like tables here is that it actually doesn't matter from the implementation of this. You just implement it, and then you can choose how to do it. And so you might have something that's a batch job today, and it's you trigger it hourly next week, and then in the future you actually run it continuously, and you don't really need to change anything.
Yeah, I love the choice. I'm just wondering what's driving.
I think it's industry specific as well. Like we're seeing a lot more, like I work a lot in the gaming, FSI space, like, imagine, like we have a lot of gaming customers here. So like sports bet, these type of customers. So they want like real-time actionable insights on how to interact with their apps or whatever that's going on. So for their industry, it makes sense to do everything in real time, right? Because we need to make a decision, we need to know what to do there, we need to make sure we're enforcing responsible gambling, all these use cases. Same in telco space. If you're working with FSI to do real-time trading, it makes sense because the use case has to be real-time. And then in Scott's case, there's other companies that sounds like real-time's a great idea, but they're like, actually, do my business users even care if that dashboard's updated once a day or once every 5 minutes or whatever? And then they go, well, actually, for the cost, it's not worth it, right? So what we're trying to give is flexibility, and then you can evolve that over time, like start with batch and then transition to real-time without having to recode the pipelines and all that kind of stuff. But there's certainly a lot of industries where real-time is absolutely critical for what they need.
So I can give another example is I'm working with another customer and they are into, waste management system. So for them, you can't, they really need IoT sensor data because they are trying to get the sense data from the trucks and all just to figure out, where they have to go and collect it and optimizing their routes as when the customer changes their needs and stuff like that also. But those are all actual real streaming use cases. But the other end is what, like Scott said, you want to have lesser compute and do it somehow incrementally, then you can also think of DLT with the batch ingestion.
Awesome. Round of applause to Reva.
I think he had one more question, but we can take it after the
One more
after
question,
this one.
sorry.
Yes.
Yeah. So how to if it's a live data, how to inject
Yes, sorry.
how long it will inject data into the table? Will you just drop the file there, or there you can run like insert and SQL, inject the table in?
So typically with Delta-like tables, you're either pointing at a cloud storage location, or you can also point to a Kafka source, if you like. And
Directly pointing to and if the Kafka directly injected.
So data come into your cloud storage, but then from there you can use like a feature like autoloader, which actually extracts and creates the table for you.
But that's like a file based. You need to drop the actual file into the cloud.
Yeah.
yeah, but you might use something like Fivetran to pull some data out of something, you can drop it there and then have it, for example.
Wow, that's yeah, we might have to call time. Let's have a chat over a slice of pizza because they've already arrived. Let's get through Emil's talk. No rush though. It's going to be really good stuff. So reimagining recommendation engines using Neo4j graph data platform. Emil Pastor, solutions architect there. Take it away. Thanks so much for chatting with us.
No worries. Yeah, thank you, Peter, and thank you, Databricks, for inviting us to and hosting the meetup. Yeah, I think I'll just have a quick intro. My name is Emil Pastor. I am a solutions architect working for Neo4j. And yeah, I think before we start, has any one of you knows or worked with Graph Database or Neo4j before? You mind raise some hands? All right, that's good. So with that said, I think I need to do a very quick introduction of what Neo4j is. All right. So the agenda for today, we'll do a brief introduction about Neo4j, what are the challenges on existing recommendation engines, and how to overcome those challenges using a concept of connected data. Yeah.
Sorry to interrupt. We didn't get your slides on the live stream.
Oh.
Apologies, folks.
No worries.
Just on your calendar, there will be, if you just unplug quickly, we can get the
You want me to send it right now?
No, 2 seconds, folks. We'll just jump onto your
We can take
calendar.
another
All right.
question if you want.
Yeah, go for it.
Sorry, you got a question?
What's your calendar app?
This one?
It's a StreamYard link.
Oh,
no,
sorry.
Just your StreamYard link.
And would you
Sure.
when would you want to use Delta tables as opposed to Delta web tables? Would all use cases naturally grab
do
these
that.
So Delta Lake, sorry,
And
Delta Lake
mute
is
your
the underlying
microphone.
file format based around hard data, columnar, and
put yourself
ASCII
in there.
transactions, reliability,
And then just share your screen.
Maybe
Share.
Just
Oh.
maybe the
Delta
entire
Lake
screen
is
if you
built
did.
on top of that, so it's leveraging what it has to offer under it, but really it's about doing
Yeah.
declarative. Okay, so just like when I run
Then
a
if
SQL
I share
statement,
it-
I'm describing my results. I'm not describing the data.
Will it share this part?
Yeah.
With Delta Lake tables, I'm describing my ETL pipeline without describing the baby steps amongst that. Okay, so they're kind of different things, but it's built on top of. Yeah.
All right, sorry about that, folks. We'll be back onto the presentation just
No
for the
worries.
benefit of the live stream. Apologies for technical issues.
Thank you. Yeah, sorry about that. Yeah, I think just to carry on, so we're gonna discuss around how to overcome those challenges using connected data via Neo4j Graph Data Platform, and we'll do a quick demonstration of recommendations engine. So who's Neo4j? All right, Neo4j, we are the connected data company. We are the creator of the graph database category and the leader in that category as well. And we developed the first graph data science platform, and we have a flexible graph data model that has worked across thousands of organizations across the globe from various verticals, right? And we're headquartered in Silicon Valley, Malmo, Sweden. So why graph database? From the industry standpoint, right, according to Gartner, 50% of Gartner inquiries that involves AI always have graph technology on top of mind of the executives. But on the technology side, according to source DB engines, as you can see, the ones in green, that's the line for graph database. And there is a big adoption of graph database throughout the years, right? And on top of that, 40 years after SQL has been standardized, the standardization organization will introduce GQL in the coming years. So that's the first standardized database language in 40 years. And much of that will be coming from Cypher query language, which is where Neo4j is based off. So that's just a quick intro around Neo4j. But then we'll go back to what we're here for. So you notice this line, if you like this, you might like that. So this is the typical line you'll see across Amazon, eBay, and all other commercial sites, right? And that's because recommendation engine has been fundamental for driving better customer experience and driving revenue as well. And today's recommendation engine has been at the core of digitization across various industries. So imagine product recommendation where you're helping companies drive more revenue streams and better customer experience, or a concept of next best action, wherein you need to drive or you need to ingest multiple data sources and real-time session-based queries. Or for example, in logistics or delivery, right? If you're going to Uber or other Uber Eats or other alternatives, companies would like to save money, but at the same time, make faster and better service. However, there are challenges on recommendation engines built on traditional systems, right? One is the batch processing to pre-compute those recommendations due to data silos, right? So we model the data, but they're not exactly connected yet, right? So we only model them logically, but we haven't connected them physically. Second is traversal to joins more than 3 levels of depth is also a problem, right? So whilst we'll be able to join them together during runtime, if we're talking about joins more than 3 or 4, that's where challenges on the computational power of your databases. And third is the overhead to generate recommendation outside database, right? So with that said, now let's reimagine recommendation engine using Neo4j Graph Data Platform. So how does Neo4j addresses those challenges built on recommendation engines built on traditional systems? One is we use the power of connected data where relationship is a first-class citizen. By first-class citizen means we store the data, the relationship data side by side with the actual data, thus creating pointers of which data is it connected to, right? Creating that fabric of information where it allows you to seamlessly traverse and make recommendations in real time because you already know how, let's say, for example, myself behaves when I purchase, let's say, in a store or in a retail. I basically just need to grab it and make recommendations out of that. And third is discovering latent insights. By establishing those relationships across your data, you will discover hidden relationships, right? Relationship that's not very obvious if we do a join, or if we don't map it as a graph. Thus, we'll be able to have better informed decision, faster time to value, and reduce risk and cost. And before we go even further around recommendations engine using Neo4j Graph Data Platform, we'll just do a quick Neo4j Graph fundamentals. So one, relationship is treated as a first-class citizen using index-free adjacency. So index-free adjacency acts as sort of like a pointer of your data, who knows what relationship it's connected to or which node it's connected to. And just like RDBMS, Neo4j is an ACID-compliant database that guarantees transactional consistency. So either it commits or it fails. And third is business agility through flexible schema. So typically, in concept of data warehouse, data mart, right? We usually start with a logical data model. We ask the data modeler and the business to do logical data model for us, and then we translate it into physical data model, which means we break down into smaller tables or we combine some of those entities together. With Neo4j, the way you mapped out or create your logical data model will be the same as how you physicalize it. And I'll be showing to you later what it means. And fourth, we have easy to use Cypher query language, which is also declarative. And if you're familiar already with SQL, there will be a learning curve, but it would not be steep because the language profile of Cypher and SQL are fairly similar. In terms of different elements of graph, this is what we call a node: Andre, Micah, and Wine, right? Node represents an entity in the graph. If we connect all of them together, let's say Andre lives with Micah or Micah likes Andre, that's what we call relationship. And this node and relationship are stored together and stored natively. And if we group those nodes or entities together, Andre and Micah together, or Wine as a standalone, we can group Andre and Micah as a person and Wine as a product. All right? And then to enrich those graphs together, we'll have a property. So it describes a node and a relationship. So you can have a property around your node or a property around your relationship. So with that said, with all of these elements, how does it relate back of one? Because even myself, I started learning SQL or RDBMS, right? So if we're talking about rows, it's all about nodes in graph. Joins, we have relationship. But remember, the relationship is stored natively. And table names are what we call labels, and columns are what we call properties. All right? So now that we learned some basic concepts around graph, let's go back to recommendation engine. So Neo4j supports better informed decision by breaking those data silos. It breaks those data silos by connecting those data stored in relational databases or in files together as a single data, interconnected data between multiple data sources. So imagine you have customer, employee, supplier, order. You can create a single graph of how each of those entities or data are connected to each other, hence, breaking the silos. And secondly, Neo4j provides faster time to value, supporting real-time insights. Since you already pre-connected those information together, you can create real-time product recommendations or recommendations on logistics or on risk mitigation because of the concept of connected data. Connected data is an analysis-ready pre-packed information bundle, right? So what it means is you just need to grab the data or the nodes that you need at that point of analysis without thinking of how, exactly how you want, what are the join keys that you need to consider and so on. And also, what we've learned so far is we have a concept of 4 V's, right? Volume, veracity, variety, and velocity. But we also need to consider 1 V, which is the varying shape and sizes of the data, right? We consider how each of those data interact with each other. And it only makes sense if we're able to traverse those information, right? That's more powerful and meaningful for business users, right? So imagine, typically you will have a wide data wherein it's one-to-many relationship, but it gets more complex, especially using traditional platform if you have many-to-many relationship, hierarchical structure, and as well as deep hierarchies, or even create hidden relationships. Like for example, if A points to C or A points to E, you can infer that C is somehow related to E, right? And lastly, we deliver impact by creating in-database analytics or complementing existing machine learning platform. So in terms of where the architecture looks like, so you have your data sources, you ingest it with your different tools, Spark, Databricks, and so on, and then you load it using Neo4j to visualize or even serve as your back-end database for your applications via GraphQL or any other microservices architecture, or even to complement your existing machine learning platform. With Neo4j Graph Data Platform, you'll be able to store your data, your connected data, and at the same time do analytics and visualizations as well. All right, so now we'll go to demonstration. So yeah, so we'll be building recommendation engine using Graph Data Platform in a theoretical store called the Neo Store, right? As a retail company who sells product, here are the things that I wanted to do. I want an end-to-end view of my data. I want to make content-based recommendation. Also, I want to find hidden relationship or infer rated relationship. Also recommend products to customer with similar profiles or even segment those customers into groups. So with that said, let's look first on the business model of a retail. So we have customers, Pravina, Michael, and Arya, and they usually purchase an order. And this order contains several products, right? And these products can be part of a product category, which is being supplied by a specific supplier, which is being sold by an employee who reports to a team leader or another employee. So this represents our data model, and this is how we will model it in Neo4j. So if I just go here, so if we go to Arrow, Arrow is our tool, Arrow.app is our tool to model the data. This is how we will model it, exactly how we draw this diagram to get, we draw the diagram on their business model. So you have the customer, order, product, category, supplier, and employees. So the next thing that we'll do is we'll load those and connect those data from several data sources. So here are the tools. For those of you who's not familiar with Neo4j, here are the tools that we're going to use. We'll have a Neo4j browser, right? So this is where you'll interact. This is basically your IDE, native IDE from Neo4j. We also have Bloom to visualize the data, and Graph Data Science platform, if you want just to do some simple prototyping of the different Graph Data Science algorithm. All right, I hope you can see, but because I can't really increase the size. So the first thing that we'll do is we'll load the data. I will not go through the code, but I'll be sharing the code in the Meetup page. All right, so what we'll do is we'll load a CSV coming in from an S3 bucket, and then start creating a customer. And then I'll show with you how the model evolves as I load the data. So if I run this query, and then I show the graph data model. So you have your first node type or node label, which is a customer, right? So the next thing that I'll do is I'll load the order data and connect that to the customer. So I load CSV with headers and then create the orders node. And then what I'll do next is connect those orders node with the customer node. So by running this query, and if we rerun it again, oops, let me just, yeah. So you now have a relationship between your customer and the order, and then we'll load the rest of the data. Okay, so whilst loading the rest of the data, the aim is for us to create this model, the one that I created in arrows.app. So it should be something similar, if not exactly the same. So after loading the data, and this data comes from my local machine, GitHub repository, and an S3 bucket. Okay, so I'll clear the scene and reload it again. Yeah, so this is I think how we load it, or how we aim it to be modeled in our data. So this is basically the interconnection of your customer, employee, product, supplier, and category data. Yeah, so that's how it was loaded. And then what will you do next, right? So now that we've managed to load the data, we can do some analytics or basic understanding of what we can discover, right? So I'll run this query in Neo4j browser. Then what I wanted to do is match, which means select a customer called Anton or Antonio, and then find his purchases, product that he purchased on order ID 10365, right? So I match this node with the purchase with this order 365 and then get the list of the products, right? So Antonio purchases a cheese. It's queso cabrales, right? But it's a cheese. All right. So, but then you can add further and basically do more match. So I also wanted to find who served this or who sold this particular order to Antonio. So if I run this query, this query. Yeah. So this was served by Robert. Okay, and this is using a different order. So you can use that using Neo4j browser, but at the same time, if you wanted to hand it over and let the business test drive it, you can also do data discovery here. Let's say show the customer view of let's say pick the same person, and then for order 10365. So you'll be able to see the customer view of Antonio for this particular order. Or if you want a full view or a full 360 view of Antonio, you can do a full customer view of Antonio. And yeah, this is all the data related to Antonio. So that's how you do it from this discovery point of view using Cypher and Neo4j Bloom. But then we can also do other analytics. Let's say find the most popular product based on the number of orders. Right? You can do a match and then do a count of the number of time each product has been ordered. So you can execute that and you get a table-like result. All right. Then what we'll do next is we'll do a content-based recommendation based on previous purchases. All right. So this is the question that we wanted to answer. Based on the customer's previous purchases, can we recommend them anything that they haven't already bought, which is similar to the product category that already bought? Like that's a very lengthy question, and it will take a lot of SQL statements for you to do that. All right. So if we do that using Neo4j, it will be a couple of match. I will not go through the detail, but basically it first matches the product that Antonio already purchased. And then the next thing is get the product that another customer purchased apart from what's common between the other customer and Antonio, and then you only make sure that those products are within the same category as what Antonio already made purchased. Then by executing this query, you'll get, if Antonio has purchased a raclette corde de vault, you can recommend, let's say, this one. Or if Antonio purchased a Chang, you can recommend Outback Lager, right? So that's all without any, data science or any analytics. That's purely based on rules. All right. So going back to the original data model, so you'll notice that you can actually create a relationship directly from the customer to the product, right? Because you already have an intermediate relationship between them. So you can sort of infer some relationship, and we'll call it rated. So that's what we'll do and we'll derive, okay? So what you can do is you'll be able to write some Cypher query that then derives a rating, which is the number of times the customer orders the product against the total number of orders. Okay, so if I execute this, so you'll get the rating. So if they ordered Konbu 4 times, but they already purchased 116 items, the rating is 4 over 116. But of course, you can change that depending on on the context of your business or your industry. All right. So if we go back to the original data model, you'll notice that we managed to create that relationship, which is customer rated to how the customer rated the product. So by creating a direct relationship between a customer and the product, you'll be able to derive more, or you can create similarities amongst customer, right? Create that map of similarities between customer. So I'll just go through with this quickly, but basically this is where you use a cosine similarity and then be able to derive the similarity between those customers. So with that, so the model will evolve again. So you will now have a similar. So this customer may be similar to the other customers. And then by using that, you'll be able to do collaborative filtering, which is basically recommend the product based on the feedback of other customers and how they rated them. So with that, yeah, so you can recommend an Outback Lager to Antonio because of the purchase of this customer, and then this is like the customer rating. Okay. And then by establishing that similarities between customer, so let's say I wanted to see how it looks like. Let me just do a refresh. So I just want to see the similarity relationship. So this is how customers are similar to each other, right? I can also create communities and segment them together. So what I'll do is I'll just switch to a different perspective. And then I'll run using data science playground, Louvain community detection. So basically, I wanted to create community based on the customer label, based on similarity relationship. Don't really care about the direction of the relationship. We'll use the cosine, or how similar they are, as the weight of that relationship, and then we'll store that data. So you can see this is how you segment your data. So you have your community number 79 with these customers, and so on and so forth. So visually speaking, so if we re-execute this query, type similar to, yeah, so the nodes with the same color belongs to the same community. And then you can use that to target, do more specific targeting with your customers, or depending on your business. All right. So just moving yeah, so this is what we do. We created a rated, we did collaborative filtering, and can create a subgraph on rated relationship. We also create similarities, and yeah, this is what I've shown already. And this is like a sample of similarity between customers. And this is what I did for the segmentation. So using Louvain community detection, you'll be able to detect or segment your network into communities. And yeah, this is how it looks like. And then with that, you can also use other data science techniques to answer different types of questions, like finding who's the most important customer, even doing supervised machine learning, predicting the link or the relationship, or even classifying a node type, or doing similarities, or even translating this network into feature embeddings, right, as part of your feature engineering exercise. And we call it like graph feature engineering. So you can supply that to your favorite machine learning platform, and yeah, you can do more. So with that said, so these are the things that we managed to demonstrate. So connecting and have an end-to-end view of the data, content-based relationship, inferring those ratings relationship, and then doing a recommendation and doing a segmentation. So yeah, other things that you can do on top of recommendation engines, you can do fraud detection, network and IT, master data management, knowledge graph, identity access management. And yeah, if you want to learn more around Neo4j, yeah, you can try to visit sandbox.neo4j.com or graphacademy.neo4j.com to learn more. All right. Any questions? Yeah.
What's the upper default? If you have your views with joins in your relation database, is there an easy way to translate those joins?
Yes. So I think you need to use at least the logical data model as a sort of like the map of how each of those tables will link together. And then as you load the data, you establish those joins up front. Yeah. Cool.
Any other questions? We do have some fabulous swag already tonight as well. Some really nice Databricks shirts. If you've got a good question to ask, you might be able to win one, as well as the DataEng hack ticket. Let's up the stakes. A DataEng hack ticket. Any other questions? Okay.
Yeah. How does it scale to, like, here we're going to say a little shot. Let's go across Woolworths, New South Wales. What is the performance going to look like? And do you have an idea of performance and the actual effectiveness?
Yep.
Across
So
the large data set?
yeah. So
that's a great question.
with the customers, we'll be able to scale up to billions of nodes, and we've tested, I think last year during the conference, trillions of nodes. Yeah, connect together. And then if you need, high availability as well, like we have a different configuration, like causal clustering, to make sure to guarantee ACID compliance. Yeah.
Grab your shirt for that one.
Oh, yes.
Yeah.
Where is your biggest market at the moment?
I'm sorry?
Where is your biggest market at the moment?
One of the biggest market, I would say, is around law enforcement and public sector. Financial services as well. I think I can publicly say CBA. And yeah, we're also working across other banks. Yeah, and also telecommunications. Yeah. Yes.
You said that while we use this graph, we can find hidden relationships. Can you give some examples?
Like for instance, what I did a while ago, there is a relationship between a customer, an order, and a product, but there's no direct relationship between a customer and a product. So you can derive those relationships either via rule-based or using machine learning algorithms in graph, like similarities or doing, let's say, link prediction, right?
Using Panama Papers, right?
Yes. So Neo4j. So if you're familiar with ICIJ, Panama Papers, or Pandora Papers, the database behind that was Neo4j. To uncover things that not so obvious. if you look at it at a tabular form, but if you connect those things together, it makes more sense, right? So yeah, I think in that particular paper, one politician got caught and got sacked in his country. Yeah. Yes.
Is there sort of like a feature to test or even score the different recommendations that's recommended?
I would say you can do A/B testing for that. Yeah, to test the viability of that.
So you test
Yeah. Yeah.
analyze the results.
Yeah.
Cool.
Cool.
Well,
Alrighty.
thank you so much, Emil.
No
I
worries.
think we've got a round of applause. Thank you. Got some really nice smelling pizza back there, a bunch of swag up the back as well. I believe you asked a very good question. So if you'd like that DataEng hack tick, it can be all yours. Just reach out to me, over a slice of pizza, and we'll get that sorted out for you. So anyway, up next is DataEng hack on the 28th of April. And then I believe we've got another meetup coming up in May at some point, probably at Nearmap. But that should be really good fun. But thanks so much for turning out in such great numbers. We're slowly getting back into the city. So, but yeah, look, really great to see you all, and enjoy the slices of pizza and stuff like that, and great networking. We'll sort of close in about 45 minutes or something like that. So yeah, enjoy the networking. Ciao for now. Cheers.